Hi everyone, so right now I'll be talking about hash codes and the extra practice question on the ninth worksheet of the semester. So first of all, let's talk about what is a hash code. So every single object in Java has a method called public int hashcode, and this will return an integer, and this integer will always be associated with that particular object. So you can overload this method and write your own hashcode method and return any hashcode that you want. However, if you don't overload it and you just use the default hashcode, this hashcode function will just return the address of the object. So that is the default. So if you want to make your own hashcode method and overload this default one, what are the qualities that it needs to have for the hashcode to be valid? So the very first one is that it needs to be consistent. And what this means is that if you were to have a hash code for an object, every time you call the hash code for that particular object, it must always return the same number. So let's say you have some object dog and its name is like Fido. Every time you call the hash code method for that dog Fido, it should return the same hash code. So in order for a hash code to be valid, it must also satisfy the equality constraint. So what this constraint means is if we have two items that are equal, they must have the same hash code. So just to clarify, every single Java object, it will have a public Boolean equals method. So what this method does is if you pass in two objects of the same type, they'll tell you if they're equal or not. So basically, if we pass in two objects and this equals method returns true, then based on the equality constraint, we know that those two objects must have the same hash code. If they do not have the same hash code, then their hash codes are not valid. So now we know if two objects are equal, they must have the same hash code. However, if two objects have the same hash code, that does not necessarily mean they're equal. So that's a very important distinction to make that a lot of people get confused with. So why don't we move on to 4.2 now? So we see this point class. So essentially this point class takes in two coordinate values, x and y, and it has a static int count. So let's see if these are valid. So the first one is public void hashcode, and it prints out this dot x plus this dot y. So this hashcode at first seems like it would work. However, if we see here, we see that the Java already has this method public int hashcode for every single object. And so if we try to overload this method with this void method, it will actually fail to compile. So this is invalid, and this won't even compile. So just to repeat, this will not compile, and it is because this hashcode should be returning an integer, and instead this one is just printing out an integer. It's not returning anything, and thus it's not overloading this public int hashcode method that is inherent to every single Java object. So this one is definitely won't work. So next, let's look at this public int hashcode. So this will return a random number each time. So this is also invalid, and the reason this is invalid is because it is not consistent. So as we said earlier, consistent means that if you call the hashcode method on the same object multiple times, it should always return the same number. So let's say we have some object and we call the hashcode the first time and we just return some random number like 1. If we call it again, that there's no guarantee that it'll return the same number 1. It could return 100 or 1,000,000 or any number really. So this hash code is not consistent. We'll just be getting different hash codes each time. So this is invalid. So let's move on to the third question. Public int hashcode returns this dot x plus this dot y, which is referring to the point class here. So this hashcode is valid. And so the reason this is valid is let's create two point classes. So let's say we have point 1 and its x value is 1 and its y value is 2. And so if we were to create another point, point 2 with the same x and y values, and we say that these two objects are equal, we will see that they have the same hash code. So this point 1, its hash code would be would be 1 plus 2. So this hash code would be 3. Similarly, for point 2, this hash code would also be 3. So thus, this hash code does satisfy the equality constraint. And we can see that it will also satisfy the consistency constraint, because for this object, if we do 1 plus 2, its hash code will always be 3. So as long as we don't change this object, its hash code will still stay the same. So thus, this is a valid hash code because it is both consistent and it satisfies the equality constraint. However, even though this hash code is valid, it will cause many collisions. So for example, let's say we have a point and its x value is 50 and its y value is also 50, then this hash code would be 100. So we see that there are many points that could have the same hash code. So for example, this point with x value of 99 and y value of 1, this hash code would also be 100. Similarly, if we had x value is 98 and y value is 2, this point's hash code would also be 100. So we can see that there are many points we can create that will have the same hash code as each other. So that will cause many collisions. So let's look at this fourth one here. Public int hashcode returns count. So if we scroll back up, we see that count is a static variable. So static variables are also known as class variables. So just to differentiate, these x and y, these are just instance variables. So this x and y value only holds true for each individual object that we create. Once we create a new point, we have to kind of wipe out this x and y value and give it new ones. However, these counts, it will be the same for every single object that we create. And what this count is basically doing is it's keeping track of the number of points that we make. So for example, if we make 1 point, its count would thus increase to 1. If we make a second point, the count would increase to 2. And that is true for every single point that we make. So let's see here. Let's say we have a public int hashcode and this will return count. So let's say I make a point. Let's say we have this point here. Let's delete this hashcode. So let's say we've only made this point here. So this count variable for the point class, it will now be 1 because we've created 1 point. So then now let's create a new point. Let's say it's point 2, and so now the count will increase to 2. So if we were to call the hashcode method on this point, it would return 2. So now let's make a third point, and now the count will increase to 3 because we've made 3 points in total. So again, if we were to call the hashcode function on this point, it would return 3 now. So earlier it would return 2, now it would return 3. So thus, this method is invalid because it is not consistent. Okay, so now let's look at the last one. This int hashcode, it will just return 4. So let's see here, is this consistent? Yes, because every single time we call this method on any object, it will always return 4 no matter what. So yes, this is definitely consistent. Similarly, if we were to call hashcodes on two equal objects, like for example, if we were to call the hashcode on this point and the hashcode on this point, they would both be 4. And so thus, any objects that are equal will have the same hashcode because every single object has the same hashcode. So the hashcode is definitely valid. However, this is a terrible hashcode because if we were to index into an array with this hashcode, everything will just stack up on top of each other. Every single object will collide. So you might as well just make a linked list to store it, and you don't even need to use the hashcode. So although this is valid, this is definitely not a good hashcode, and it will cause, literally everything will cause a collision.